sometimes finding the actual integral can be difficult. I mean, there are some functions that actually we can't integrate, we just don't know how. So we need to have a good way of approximating the answer. And the way that our syllabus would have us look at it is what's known as the trapezoidal rule. So instead of estimating with a rectangle, which is what we were doing before, they say, well, hang on, why don't we just join the tops of these lines up and we'll get a trapezium. Yes, it's still, in this case, an overestimate, but it's certainly going to be better than the rectangle. So if we join that up, and if you remember your formula for a trapezium, half the perpendicular height, which in our case would be the difference between B and A, and then the sum of the parallel sides, which would be whatever the function value is at A, plus whatever the function value is at B. Depending on how many trapeziums we draw, just like we saw with the rectangles, the better the estimate we're going to get. So how about I just chop that in half? And you can see on our particular graph there, it certainly looks like the overestimate's smaller than the first one. So what would we do there? Well, we've got to find the area of both of these trapeziums. So the difference between C and A and difference between B and C, if we pick C sensibly, i.e. halfway, then the difference between C and A is going to be the same as the difference between B and C, which then would allow me to factorise these two. And I've gone with C minus A. I mean, you could have gone with B minus C. It doesn't really matter. But you'll notice we get twice the function C there. So function A plus twice the function C, because it's involved in both of the trapeziums, and plus function B. Well, let's take it another step further. Let's say we split it up into 3. But again, if we choose those points C and D sensibly, then C minus A is going to be the same as D minus C, is going to be the same as B minus D, and we could factorise. And now a pattern starts emerging. It appears, and I guess it makes sense if we look at our picture, that when it comes to our function values, we always get twice the function values that are in the middle. Now, that makes sense because the ones that are in the middle of A and B are involved in 2 of the trapeziums. So I guess our formula, I could write something like this. Yes, we know the area would be exactly the integral from A to B. I could approximate it with h on 2, so the height of our trapezium, C minus A, D minus C, B minus D, whichever we want to choose, over 2. The y values then of each of these points, I suppose the neatest way I can think about it is, well, if I call the first one y0 and I call the last one yn, it'll be one of those, and the neatest way I could think of it is to simply say, oh, well, 2 times the others. So there's my formula, 2y the others. You know, you're going to have all these trapeziums. We know that the area of a trapezium is perpendicular height on 2, and then all we have to worry about is all those parallel sides. We're going to have one of the end ones and 2 of all the ones in the middle. So all the other ones. That perpendicular height then would simply be whatever B minus A is divided by however many trapeziums that we're going to draw. But notice, when it comes to the actual function values, you're always going to have one more function value than you have trapeziums. See our picture we got here, there are 3 trapeziums, but we have 4 function values. Now sometimes they might word the question and say using so many function values rather than saying using so many trapeziums. So just be careful with that and make sure you know what you're substituting in. N is the number of trapeziums. Also, instead of calling them trapeziums, sometimes they just call them strips. Sometimes they'll call them intervals. What else have I seen them call? Sometimes I'll send them call them sub-intervals. But yeah, hopefully it will make sense when you read through the question. So let's do one. We're going to estimate under this particular curve the square root of 4 minus x squared, because of course at this stage we don't actually know how to integrate that one. So the heights, they've told me 4 intervals. So therefore I'm going to divide by 4, 2 minus 4, so half. We're going to be going up by half. I drew up a little table of values then, and The way I do this, there's the formula, is my table of values just above it, just to remind myself. I say, righto, I know it's 1 times the end ones, and all the others I'm going to multiply by 2. So when we sub that all in, we get 2.996. Now, whilst I said I don't know how to integrate, I do know how to find the exact value, because we're, of course, looking at a circle. So the exact value turns out to be pi. So there's our approximation. How good is our approximation? I suppose we could work out the error. Difference between the exact amount and my approximation, divided by that exact amount, multiplied by 100. So by using 4 trapeziums, I've come up with an error of about 4.6%. And obviously, the more that we use, the better the approximation will be. There is an alternative way of setting that I saw once, which I thought, oh, it's not too bad. So there's our table of values. There's the answer. Now have a look at what the answer is actually doing. Top of the fraction, there is that 2, so the end value, twice all the ones in the middle, plus that. So that's still there. On the bottom of the fraction, see that pattern of 1, 2, 2, 2, 1? You just add up those numbers. 1 plus 2 plus 2 plus 2 plus 1. And then we just multiply it by b minus a. 2 minus 0. And surprise, surprise, it comes up with the same answer. So that's an alternative way of setting out the answer. Some people like to do it that way, because they just go, bang, they actually use a formula. They just go, right, let's set it up. Here's the fraction. Top of the fraction, I'll do that, right, the end values plus twice the middle ones. On the bottom, I just repeat the pattern, and then I'll multiply it by the 2 endpoints, the difference between those. That's all for today.